faithfully sharing value and exploring great books from around the world. Hello, this is Sally Talking Books. Today, the book we're interpreting for you is called The Rise and Fall of Japan's Electronics Industry. In the early days of China's reform and opening up, Japanese household appliances were super popular nationwide. Many folks born in the 1970s and 80s probably still remember the Toshiba color TV ads with Noriko Sakai. It even became a generational memory. Back then, Japan's electronics industry was absolutely booming. Besides household appliances selling like hotcakes worldwide, they also dominated in areas like semiconductors, holding a huge chunk of the market. Um, and in the global top 10 semiconductor company rankings, Japan's NEC took the top spot. Toshiba was second, Hitachi third. At one point, Japan's electronics industry had an annual trade surplus of 10 trillion yen, so much so that the first line of the NHK documentary, Electronic Nation, said electronics became another big earner of foreign cash after cars. But starting from 2000, that trade surplus gradually shrank until 2013, and just the trade deficit for computer and comms gear alone topped 3.7 trillion yen. Nowadays, Japanese electronics makers like Toshiba and Sony are mostly in the red. Key businesses like CPU and GPU design are pretty much abandoned. Industries such as wafer making, foundry work, packaging and testing, and LCD panels got overtaken by Chinese and Korean firms. Even in semiconductor gear, it's a losing battle overall. The only thing Japan's electronic scene can still brag about is raw materials and components like resistors and capacitors. So why did this happen? In The Rise and Fall of Japan's Electronics Industry, the author Yoshio Nishimura offers his take. The book's author, Yoshio Nishimura, is basically an eyewitness to both the rise and fall of Japan's electronics biz. He's got a PhD in engineering from Tokyo Tech. Early on, he did semiconductor research at the University of Montpellier in France. After coming back, he was editor-in-chief of Nikkei Electronics for 12 years. Nikkei Electronics is Japan's top authority in electronics magazines. At its peak, every executive at Japanese electronics firms with over 300 employees had a subscription. After 2002, Yoshio Nishimura also became a professor at the University of Tokyo and Waseda University, writing textbooks like The Direction of the Semiconductor Industry and Information Industry Theory. The Rise and Fall of Japan's Electronics Industry is Nishimura's book for regular readers. It's about 200,000 characters long, breaking down why Japan's electronics tanked across 6 areas: international politics, industrial policy, the Zaibatsu system, business models, tech paths, and management strategies. All right, I'll break it down for you one by one. First up is international politics. A country's industrial growth is deeply connected to the global political scene. Japan's electronics boom, well, a big part of that came from America's backing. After the Korean War broke out, the US started boosting Japan's industry, wanting Japan to be a rear base supplying goods for US military ops. So America pumped tons of cash into Japan and handed over loads of civilian and military tech. Plus, after helping with civil defense and military stuff, as the Cold War heated up, America shifted electronics focus to military needs, which actually opened doors for Japanese consumer electronics in the US market. With Japan exporting radios, TVs, and such to America, their whole electronics sector took off fast. At the same time, Japan's government used this government-industry-academia model, grabbing the moment to make Japan's semiconductor industry shoot up. In this model, government means the state, industry means businesses, academia means universities. Basically, it's about pooling resources from government, industry, and academia to grow the economy. Japan's government played a crucial part in the electronics boom. First, funding-wise, MITI, Japan's trade ministry, teamed up with business groups to pour in 70 billion yen, giving industries plenty of cash. Second, in 1971 and 1978, Japan passed laws like the Special Measures for Electronics and Machinery Promotion Act and the Special Measures for Machinery and Info Industry Promotion Act, setting legal groundwork for semiconductor and electronics growth. MITI pulled all the big companies together to share resources. Under MITI's lead, each firm picked specialties, like giving Nikon and Canon lithography machines, Toshiba, NEC, Mitsubishi memory chips, and Mitsubishi Hitachi power semiconductors. This avoided doubling up on R&D and kept high barrier tech from being ignored. So, Japan's whole semiconductor sector grew across materials, design, manufacturing, packaging, testing, letting top firms like NEC, Tokyo Electron, Nikon, Canon, Hitachi, Tokyo Semitsu, Sony, Fujitsu, Mitsubishi Electric leap ahead in tech and business. The Japanese government also fully mobilized academia, bringing together talent from universities and government research institutes with R&D teams from giants like Fujitsu and Toshiba. Tech breakthroughs. 4 years after this policy started, Japanese universities and tech firms scored about 1,000 patents, putting Japan on par with the US in VLSI tech, proving the government industry academia model a huge success. From 1970 to 1985, Japan's electronics output quintupled, domestic demand tripled, and exports grew 11-fold. In many areas, American tech firms got pushed back hard by Japanese companies. Take memory chips. Japanese firms were so competitive that Intel had to bail on that business. Honestly, the late 80s to early 90s was the golden peak of Japan's electronics glory. But mid-1980s brought changes. US-China entered a honeymoon phase, and US-Soviet tensions eased. Suddenly, propping up Japan felt totally unnecessary to America. Plus, the power balance shifted. Japan became the world's #2 economy and started challenging the US economically. Against this backdrop, America flipped its Japan strategy from supporting industrial growth to actively suppressing it, especially electronics. As a pillar of Japan's economy, it naturally became America's prime target. So how did America take down Japan's electronics industry? First move, devaluing the dollar against the yen, which gutted Japan's export price edge. Second move, anti-dumping lawsuits. In 1985, the U.S. Semiconductor Association filed anti-dumping charges with the Commerce Department, claiming Japanese firms sold too cheap. After negotiations, the U.S.-Japan Semiconductor Agreement introduced price monitoring, meaning cheap prices, once Japan's core advantage, vanished overnight. And third move, backing South Korean and Taiwanese firms. America pumped money and tech into Taiwan and Korea, building rivals to undercut Japan in mid or low-end markets and crush their profits. When Japanese firms saw their core markets under attack, they couldn't spare resources to challenge American dominance in high-end sectors. After this combo of blows, Japan's electronics growth slowed hard, just 1.5 times expansion from 1985 to 2000. Compare that to the previous 15 years when output had surged over fivefold. Post-2000, with TSMC, Samsung, LG, ASE, and other Korean or Taiwanese firms rising, Japan's electronics entered decline. By 2013, output was just 11 trillion yen, less than half its peak. Now, Japan's electronics downfall wasn't just U.S. policy shifts. They shot themselves in the foot, too. Top of the list? Overambitious industrial policies. As mentioned earlier, after Japan's economic rise, they kept challenging America economically. The big one? Battling America for industry standard-setting power, the ultimate high ground. If Japanese firms controlled standards, they'd lead the industry and rake in profits through patents. But America and Europe weren't handing over that power without a fight. So Japan decided to build its own tech ecosystem. The book's author calls this Japan's electronics sakoku, a self-imposed lockdown. Take telecom. In the 2G era, GSM was the global standard. China Mobile and China Unicom's 2G networks used GSM. 80% of global 2G networks used it. CDMA was second, used in North America and China Telecom, but Japan stubbornly pushed its own PDC standard. Since foreign phones supported GSM, CDMA, but not PDC, Japan's mobile market became a walled garden. Same with computers. Japan mandated Japanese language support for imports, creating two big hurdles. First off, back then, Japan had its own Japanese language processor. Users were used to pairing it with computers, which caused compatibility headaches. Second, computers had limited memory back then, so processing Japanese kanji and katakana was often hardware-based, kind of like Lenovo's Han card in China, that also led to compatibility issues. Japanese companies exploited these compatibility problems to shut out foreign computer firms, grabbing almost the entire domestic market. The Japanese government also kicked off the Tron project, a plan to merge OS and CPU, aiming to build Japan's own computer system, separate from the US Wintel alliance. Sadly, this drew US Congress backlash. America pressured Japan, slashing Tron's funding. Without government backing, Tron barely survived domestically. In the author's view, this locked Japan's computer industry in a sakoku state, incompatible with Western standards, usable only at home. That weakened Japan's global presence and cost them huge emerging markets. Objectively, Japan's push for industry standards wasn't misguided, and leveraging the home market to grow their industry makes sense. But electronics, especially high-performance CPUs and OS, have sky-high tech barriers and need massive cash and markets. With Japan's tech limits and small domestic market back then, they couldn't support such a huge system. Though, pinning all the blame on Japan's government isn't fair. Japan's keiretsu system was another big reason why Japanese firms lost out internationally. Historically, Japan formed 6 major keiretsu: Mitsubishi, Mitsui, Sumitomo, Fuji, Sanwa, and Daiichi Kanyo. These groups, since the Meiji era, kept feudal, closed traits. Firms held shares in rings tied by finance and blood ties. Under the keiretsu system, corporate structures got rigid, and firms turned conservative on tech innovation. The first bad fruit of the keiretsu system was killing off tech innovation. For instance, chips are becoming more integrated. Many design firms now pack multiple components onto a single chip. But Japanese firms stuck to outdated discrete methods, mounting components individually on boards. Though performance was solid, they lost completely on price and cost competitiveness. With supply chains locked within keiretsu, domestic monopolies, and national loyalty buying, uncompetitive Japanese products still found buyers. Firms could profit without innovating, zero motivation to upgrade tech. The keiretsu system's second flaw: prioritizing capital gains over long-term growth. Post-Plaza Accord yen surge. PM Nakasoni's cabinet cut rates and taxes to fight deflation, flooding markets with cash. Keiretsu power brokers cared only about soaring capital returns. Versus high-investment, high-risk electronics, Keiretsu dumped billions into stocks and property. First move: devaluing the dollar against the yen, getting Japan's export pricing edge. Second move: anti-dumping lawsuits. In 1985, the U.S. Semiconductor Association accused Japanese firms of predatory pricing. Result: the U.S.-Japan Semiconductor Agreement imposed price monitoring. Japan's core advantage, cheap prices, vanished overnight. Third move: backing South Korean and Taiwanese rivals. America funneled cash and tech to Taiwan, Korea, building competitors to crush Japan's mid- or low-end profits. With home markets under siege, Japanese firms couldn't challenge U.S. high-end dominance. After this combo, Japan's electronics growth crashed. Just 1.5 times growth from 1985 to 2000 versus 5 times previously. Compare that to the previous 15 years when output had surged over fivefold. Post-2000, with TSEC, Samsung, LG, AC, and other Korean or Taiwanese firms rising, Japan's electronics entered decline. By 2013, output was just 11 trillion yen, less than half its peak. Now, Japan's electronics downfall wasn't just US policy shifts. They shot themselves in the foot too. Top of the list? Overambitious industrial policies. As mentioned earlier, after Japan's economic rise, they kept challenging America economically. The big one? Battling America for industry standard setting power, the ultimate high ground. If Japanese firms controlled standards, they'd lead the industry and rake in profits through patents. But America and Europe weren't handing over that power without a fight. So Japan decided to build its own tech ecosystem. The book's author calls this Japan's electronics sakoku, a self-imposed lockdown. Take telecom. In the 2G era, GSM was the global standard. China Mobile and China Unicom's 2G networks used GSM. 80% of global 2G networks used it. CDMA was second, used in North America and China Telecom, but Japan stubbornly pushed its own PDC standard. Since foreign phones supported GSM, CDMA, but not PDC, Japan's mobile market became a walled garden. Same with computers. Japan mandated Japanese language support for imports, creating two big hurdles. First off, Japan had standalone Japanese processors. Users paired them with computers, causing compatibility headaches. Second, limited computer memory back then meant Japanese character processing required hardware, like Lenovo's Han card, which also created compatibility issues. Japanese firms exploited these compatibility issues to shut out foreign computer companies, dominating nearly the entire domestic market. The Japanese government also launched the Tron project, a plan to integrate OS and CPU, aiming to build Japan's independent computer ecosystem separate from the US Intel alliance. Sadly, this drew US congressional opposition. America pressured Japan, slashing Tron's funding. Without state support, Tron barely survived domestically. According to the author, these moves locked Japan's computer industry in isolation, incompatible with Western standards, usable only at home. This weakened Japan's global tech presence and cost them massive emerging markets. Objectively, Japan's push for industry standards wasn't wrong, and leveraging their market to grow domestic industry makes sense. But electronics, especially high-performance CPUs and OS, have sky-high tech barriers and require massive funding and markets. Given Japan's tech limits and small domestic market back then, they couldn't sustain such a huge system. Still, blaming it all on Japan's government isn't entirely fair. Japan's keiretsu system was another major reason Japanese firms lost globally. Historically, Japan formed 6 major keiretsu: Mitsubishi, Mitsui, Sumitomo, Fuji, Sanwa, and Daiichi Kanyo. These groups maintained feudal, closed structures since Meiji. Firms held shares in rings, tied by finance and blood. Under keiretsu, corporate structures grew rigid, making firms conservative on tech innovation. The first damaging outcome of keiretsu was stifling technological progress. For example, modern chips are highly integrated. Design firms pack components onto single chips. Yet Japanese firms clung to outdated discrete methods, mounting components individually. Though performance was decent, they lost completely on price and cost competitiveness. With upstream and downstream firms all under the same keiretsu, oligopoly at home, no competition, plus Japanese buying local, many uncompetitive Japanese products still had a market. Even without innovating, Japanese firms could coast along making money. Zero drive to upgrade tech. The second bad outcome of keiretsu: corporate choices lean toward capital gains over long-term growth. After the Plaza Accord yen surge, PM Nakasoni's cabinet cut rates and taxes to fight deflation, flooding markets with cash. Under keiretsu, the real power players cared only about fat returns from capital gains. Versus high-investment, long-term, high-risk electronics, Japanese keiretsu dumped big cash into stocks and property. And poor patents for 4G standards got split among Chinese, American, and European firms, locking down the tech path. That's all for now. Finally, Let's chat about Japanese electronics firms' business strategies. At first, Japanese electronics were seen as cheap and so-so quality abroad, but they won on low prices. After booming in the 70s and 80s, Japanese quality caught up and beat many Western firms. For instance, Japanese memory chips even threatened giants like Intel, locking firms into a mindset spare no cost for top quality to win the market. That strategy might have worked in the mainframe era, but after many computers, workstations, PCs, smartphones hit the scene, things changed big time. The biggest shift? How fast stuff updates, especially consumer gadgets. It's changing daily. Would anyone use a computer or phone for 10 years? Computers get swapped every 3 to 5 years. Phones? More like 1 or 2. If the whole device is outdated, super long lifespans for its parts are pointless. But Japanese firms missed this shift, stuck in old thinking, making parts as high quality and long lasting as possible. Meanwhile, Korean firms read the market clearly. Component lifespans just need to match product upgrade cycles. If workstations last 8 years, Koreans make memory chips last 8 years. If PCs get replaced every 5 years, their memory chips last 5 years. Though Japanese chips last longer, this makes zero business sense. It just jacks up costs, not only failing to boost competitiveness, but driving customers away with higher prices. Some Japanese scholars defend the industry's decline, claiming Japan didn't lose on technology. But this view ignores the tech cost link. True mastery means cutting prices while keeping quality. That wraps up the key insights from the rise and fall of Japan's electronics industry. Yoshio Mishimura wrote this to distill lessons from Japan's electronics journey. Some successes are worth studying, like Japan's government industry academia model, pooling resources for industrial growth. Japan's failures also offer warnings for us. Industrial policies must fit a nation's actual tech level, talent pool, market size, and industrial strength. Never repeat Japan's disconnect from reality. Also, stay flexible on business models and tech paths. Choose whatever boosts tech progress and market competition. Wisdom from others can polish our own jade. Japan's electronics saga is China's reference book. May today's insights inspire you. We sincerely hope China's electronics industry achieves greater success. All right, that's our interpretation of Japan's electronics journey. Notes are below the audio. See you tomorrow.